You can ignore the middle course because middle course is just in the middle, not much useful. There's not that many questions asking about the middle course at all. So it's either upper course or lower course, and the characteristics are usually not always, the opposite. Okay, so gradient, we have steep gradient because small amount of river discharge. Steep slope is uphill, upland, usually high up in the hill slope. Lower course, we have gentle gradient because of lateral erosion. So dominant erosion process are vertical erosion at the upper course, so the river down cutting the riverbed. At the lower course, we have dominant lateral erosion, winding river channel, pushing the hill slope behind, and that's why we usually have a gentle, and also it is usually near the river mouth. Okay, so it is near the sea level, so gradient usually decreases in general anyway. Okay, cross section of the river profile, always be careful, it's V-shaped all the time. Okay, in river environment we always say it's V-shaped. U-shaped valley exists, but that's for glacial valley. Okay, if a glacier melt, it leaves behind a U-shaped valley, but for river, no matter how wide and how flat it looks like, it is still a V-shaped valley because you can't see the river channel underneath. Okay, all you see is a piece of flat land. The water blocks the view of the riverbed, but if you can have a cross section, you just cut the river in half like an orange, then you will still see a V shape. Okay, even though we call it a very flat and wide V shape. Okay, always V shaped. Okay, for river. Channel path relatively straight with small bends around obstacles because river discharge is small, not much rainwater collected, not much overland flow, so the river channel is usually narrow and shallow, and the river discharge cannot move the obstacles, they have to flow around it. Okay, at the lower course, it's winding with big bends because a lot of tributaries have already joined in this table, so the river discharge is high, velocity is usually high, energy is high, so it can overcome the obstacles, erode them, or simply even erode the land. Okay, so at the lower course, it's a winding river with big bends. Okay, the bends are so big, at some portion of the big bends it look quite straight. Okay, channel shape, narrow, shallow, and rough at the upper course because, as we mentioned, a lot of sediment, big and angular, and rough sediment over here, large and angular. That's why we have narrow, shallow, and rough riverbed because of sediment. At the lower course, we have wide, deep, and smooth riverbed. We already explained wide and deep because large discharge, a lot of tributary join, a lot of lateral erosion, so wide and deep river channel. Smooth because of erosion, so over time, over the course of the river, attrition has usually erode the sediment, break down the load into smaller, round, and fine sediments, so they are smooth and small. Okay, velocity at the upper course are usually low because, as we mentioned, they are rough riverbed, so channel friction is high, wet perimeter is quite rough, angular, so high channel friction means that velocity is low because the river has to overcome the channel friction. Okay, but at the lower course, we have relatively high average velocity. Keyword is average because at the river mouth, or when the river enters the lake, when it enters a large body of water, velocity drops a lot. Okay, that's why they're usually that position. So velocity on average is high, even though the river channel has been flat on the lower course. It's gentle and flat river channel, but because the riverbed is so smooth, it has overcome or compensate for the reduction in gradient. Okay, so it's kind of like if you have slippery floor, then you can slide around, right? If you just have a bottle of soap or shampoo pour into the ground and you can just slide around, right? So smooth riverbed means you can slide around, but you can't really slide around in a rough riverbed, right? I think I told you to imagine running on the pebble road, right? Kind of related to discharge and velocity. So low energy in general because low discharge, high energy in general for lower cost because of high discharge, high velocity, but it is low in river energy when it enters large body of water. So the river, imagine I am like the river. I'm running, river is running, and all of a sudden I hit a wall. What do? I stop, right? I stop in the standstill because I can't penetrate through the wall, right? So, but the river is different. When the river joins a lake or joins the sea, it's kind of like hitting a wall because this large body of relatively stagnant water. Okay, so the flowing river hits the stagnant water body, so it merges and basically slow down. Okay, good. Yeah, so size of the lode at the upper course large and angular, at the lower course small and round. Attrition, as we mentioned. Roughness of riverbed explained. Channel friction explained. Okay. Any questions?